Three charges are placed at the vertices of an equilateral triangle. The charges are Q1, Q2 and Q3. Charge of Q1 is Q, charge of Q2 is Q, and charge of Q3 is minus Q. The force on the charge Q1 by the charge Q2 is F vector plus Q. The direction is away from the charge Q2 because both the charges, that is Q1 and Q2, are like charges. Next, the force on the charge Q1 by the charge Q3 is F vector minus Q. Its direction is towards Q3 along the axis because Q1 and Q3 are unlike charges. The resultant vector of the force on the charge Q1 is F1 vector. The force on the charge Q2 by the charge Q1 is F vector plus Q. The force on the charge Q2 by the charge Q3 is F vector minus Q. So the resultant force is F2 vector. The force on the charge Q3 by the charge Q1 is F vector plus Q. The force on the charge Q3 by the charge Q2 is F vector plus Q. So the resultant vector is F3 vector. The resultant vectors F1 vector, F2 vector and F3 vectors are calculated by vector addition by parallelogram method. This is an equilateral triangle, so interior angle is 60 degree and exterior angle is 120 degree. The force on the charge Q1 and force on the charge Q2 are same because both the charges are same. So the net force on the charge Q is equal to F1 vector is equal to F2 vector. Here the external angle is 120 degree. The net charge on plus Q is equal to F1 vector is equal to F2 vector. We know that. So the magnitude of F1 vector is equal to F2 vector is equal to square root of F plus Q whole square plus F minus Q whole square plus 2 F plus Q F minus Q cos 120. Cos 120 value is minus 1 by 2. This 2 will be cancelled out. So the resultant vector, that is magnitude value, is equal to 2fq square minus fq square, which is equal to square root of fq square. Taking square root for fq square, we get fq. So this is the net force on the charge plus q is equal to fq. Next we calculate the force on the charge q3, that is minus q. Here the angle is 60 degree. The resultant vector can be calculated by again parallelogram method. So F3 vector, magnitude of F3 vector is equal to square root of F plus Q square plus F plus Q square plus 2 plus Q, that is 2F plus Q, F plus Q cos 60. Cos 60 is 1 by 2. So simplifying these values, we get square root of 3fq square. Square root of fq square equal to fq and square root of root 3 is equal to root 3. So the net force on charge minus q is equal to root 3 fq. Next we calculate the force on the charges. It is not asked in this question. So anyway we calculate it. The net force on the charges F is equal to F1 vector plus F2 vector plus F3 vector. So here the vector is missing. Just a bit. The individual force on the Q1, Q2, Q3 we have it. So here we have to calculate the addition vector of F1 and F2 vector. So consider this portion. Here this is F1 vector its magnitude is FQ, and this is F2 vector and its magnitude is FQ. Next, F3 vectors, it acts on downward direction. So next, this angle, for to find out the addition of F1 and F2 vector, we need the angle. So this is 60 degree, this is 60 degree. So the angle between this F1 and F2 vector is 60 degree according to linear pair. Uh, so this one is, so here this angle is 60 degree. Now we calculate the sum of F1 vector and F2 vector according to parallelogram method. So fq square plus square root of fq square plus fq square plus 2 fq cos 60. Cos 60 value is 1 by 2. Simplifying this one, we get square root of 3 fq square. Taking square root for this one, we get root 3 into fq. So the net force is addition of F1 and F2 vector plus F3 vector. So addition of F1 and F2 vector is upward direction, but F3 is downward direction. So we give a negative value for F3. So substituting its magnitude in this equation, we get 0. So the net force on the charges is equal to 0.